Today we are going to solve some trig equations. Let's start with this one. What you'll notice up at the top of the screen is what our constraint is. That means that I'm only going to want values for x that are between 0 and 2 pi, and we're solving in radians. Okay, so the first thing that I'm going to do is isolate the trig function. So I'm going to subtract 5 from both sides, and then I'm going to divide both sides by 3. You'll notice that -1/3 is not one of the standard angles on the unit circle that you would recognize. So we're going to have to use our calculator to solve this one, and I'm going to open up my calculator. And the first thing that we're going to want to do is find the reference angle. The reference angle is the positive angle in the unit circle. A reference angle looks like this. So a reference angle, let's write a definition here. A reference angle is the positive angle formed with the x-axis and the terminal side of an angle. So if you look at the quadrants, in quadrant 1, your reference angle is here. In quadrant 2, your reference angle is there. In quadrant 3 here. In quadrant 4 over here. Now, the reason it's nice to find a reference angle and a value is because of the symmetric property in the unit circle. Once I have a value, I can reflect it over the axes. So again, the first thing that we're going to want to do is find the angle in the first quadrant that creates a sine value of 1/3. It's going to be the positive angle in the first quadrant, and that will give me my reference angle. So we're going to make sure our calculator is in radian mode, which mine is not. So I'm going to highlight radians, and to do that, we're going to use inverse trig. So we're going to say x equals inverse sine. Actually, I don't want to say x, I want to say reference angle. My reference angle is equal to the inverse sine of positive 1/3, and that will tell me the angle in the first quadrant that returns a sine value of 1/3. So second sine of 1 divided by 3. So now I know my reference angle in radians is 0.34 rounded to the nearest hundredth. So I'm going to write a little r up there for radians. Now, I know that sine is negative, and sine is negative in the third quadrant and in the fourth quadrant. So I want to find the angle with the reference angle in the third quadrant and the one with the same reference angle in the fourth quadrant. So my angle, x, is going to be equal to, in the third quadrant, pi plus 0.34. I went around pi and then 0.34 radians more. In the fourth quadrant, it's going to be 2 pi minus 0.34. I did not go all the way around. I stopped 0.34 short of there. And then at that point, since it's not an exact answer, I would plug it into my calculator. Pi plus 0.34 is 0.34 nope, sorry. Let's try that again. It is 3.48 radians. And 2 pi minus 0.34 is 5.94 radians. And that is how you solve that kind of equation. Now remember, the first thing you do, you isolate your trig function. Then you find the reference angle. And the reference angle is the positive angle in the first quadrant that will give you the positive value for your sine or whatever trig function you have solved for. After you find the reference angle, you determine which quadrants your angle's in by looking at the sign of your trig value. So since sine here is negative, I know that it has to be in the third or fourth quadrant. Had it been positive, it would have been in the first or the second quadrant. And then at that point, you use that reference angle to find the angles in each of the quadrants. That will give you that result. Now, I want to solve a quadratic. Again, I want only answers between 0 and 2 pi in radians. This tells me radians. Okay, so to solve a quadratic, I am going to, in this case, I don't have anything not squared. So again, I'm going to solve for my trig function. I am going to subtract 3 sine squared x from both sides. And then I am going to subtract 1 from both sides. We'll divide both sides by 4. And then we're going to take the square root of both sides. When that happens, I get plus or minus 1/2. Now we're lucky at this point because 1/2 is an answer I have on my unit circle. Think about the first quadrant. Sine is 1/2 at pi over 6. So now I know that's my reference angle, and I'm going to have an angle in every single quadrant because sine is both positive and negative. I'm going to have 1 over here with that reference angle, 1 over here with that same reference angle, and 1 over here with pi over 6 reference angle. So my answers would be pi over 6. In the second quadrant, it would be 5 pi over 6, which is pi minus pi over 6. In the third quadrant, it would be 7 pi over 6. That's pi plus pi over 6. And then in the fourth quadrant, it would be 11 pi over 6. 2 pi all the way around minus pi over 6. And those are my solutions between 0 and 2 pi. Here's another one to solve. Again, isolating your trig function. We'll add 3 to both sides and divide both sides by 2. Notice, radians only between 0 and 2 pi. Now, when is sine? Well, let's see. Do you recognize that on the unit circle? All of you should be saying no. That's not a standard angle in the unit circle. Now, plug it into your calculator, and something interesting happens. Let's see. Let's pull up my calculator. So, second sine, again, I'm still in radian mode, 3 divided by 2, or 1.5. Now, it says error domain. Think about why that happened. When is sine over 1? Answer to that question is never. Sine is never over 1. That is the y-coordinate on the unit circle. Therefore, this is no solution. So look for that to happen. I always end up having a kid say to me, something's wrong with my calculator. There's nothing wrong with the calculator. You have to put in something that makes sense, and this to the calculator does not make sense. Okay, here is another one. Again, a quadratic, but this time I'm going to have a middle term. So Anyone who's bothered by it can make a substitution. We can let a equal cosine of x. So that would be 2a squared minus 9a equals 5. We're going to solve this quadratic like any other. We'll subtract 5 from both sides. We'll use the AC method. 2 times negative 5 is negative 10. I need two numbers that multiply to negative 10 but add to negative 9. That would be negative 10 and positive 1. So I'm going to split that middle term. And then factor by grouping. My first two terms have a GCF of 2a. And my last two terms have a GCF of 1. Now my a minus 5's match. Now, I've gotten to this point, I can substitute in cosine. Now, I'm going to set each of the factors equal to 0. That gives me cosine of x is equal to 5, or cosine of x is equal to negative 1/2. Cosine is never over 1, so this one gives no solution. But cosine is a half, a negative half actually, but in the first quadrant it's a half at the angle pi over 3, which tells me my reference angle. Now, cosine is negative in the second quadrant and also in the third quadrant. Each of these with the same reference angle because it's symmetric. So my first angle here is going to be pi minus pi over 3, or 2 pi over 3. And my second angle in the third quadrant is going to be pi plus 2 pi, or pi plus pi over 3, which would be 4 pi over 3. So these are my solutions. Next, I want you to try and solve this problem. Press pause on your video player, and when you're ready to see the answer, press play again. These are the solutions. If that's not what you got, go back and check your work, and also check with a neighbor. Now, we've been solving in radians. I'd like to solve some in degrees. So, first, again, set everything equal to 0. And I'd like to factor this. So we'll look at the AC method. 2 times negative 1 is negative 2. I need two numbers that multiply to negative 2 but add to positive 2. Are there any? No. So we've got to use the quadratic formula. Sine of x is equal to the opposite of b plus or minus the square root of b squared minus 4 times a times c, which would be plus 8, all over 2a. Minus 2 plus or minus the square root of 12 over 4. That's going to simplify even more. Minus 2 plus or minus 2 square root of 3 over 4. Simplifies even more. Oh my goodness. Minus 1 plus or minus the square root of 3 over 2. Yay! That's as far as I can simplify down. Clearly, there is not a standard angle in my unit circle, so I'm going to have to use my calculator, and let's see. Sine of x can equal, let's pull up the calculator. So, minus 1 plus the square root of 3, and then divided by 2. So it can be 0.366. I'm going to write that down. And I'm going to want the reference angle for that. inverse sine of 0.366. But what you're going to notice is in my calculator, I am not going to just type 0.366 over again. I want to eliminate rounding errors if I can. So we'll press second sine, second answer. Except that, ooh, so close. I've got to make sure that I am in degree mode, because if you remember, we're solving in degrees this time. Okay, back to this. So my angle is 21.5. Now, I also need to figure out the other option, which would be -1 minus the square root of 3 all over 2. So let's check that out. Let's see, -1 minus the square root of 3 divided by 2. Okay, that's -1.366. Sine is never less than -1, so this doesn't give you any solutions from this. So now I know that my reference angle is 21.5. Sine here is a positive number, so that means I'm going to have a solution in the first quadrant, and in the second quadrant, same reference angle, 21.5, 21.5. So my first angle is simply the reference angle. My second angle is going to be 180 minus 21.5, which is 158.5. Now, again, we're going to solve this. We'll factor out sine of x. Notice we're in radian mode. And now that it's factored, sine of x is equal to 0 or sine of x is equal to 1. Both of these will yield standard angles on my unit circle. Sine is 0 at 0 and pi. Sine is 1 at pi over 2. And that's it. Check online for your homework and begin working on it. Have a great day.